Hello, greeting everyone. Today we are going to talk about a very different from our previous discussion about Gauss's law, Ohm's law, Coulomb's law. This is very different but very simple to understand if you understand the basic terms. So this is our objective for today. We are going to learn about the basic and how to identify the Kirchhoff's law and how to use these two laws in terms of answering the questions in the circuits. So without further ado, let's get started.
So before we begin, we have to understand first the important terms. First is the branch. The element of our circuit, such as voltages and current sources or loads such as like resistors, they represent a branch. These branches are interconnected or connected in a point, especially when they are connected in a parallel circuit. So that point is called node. Next is loop, which is a closed path in our circuit. So here we have our fundamental theorem of network topology, which states that the number of branches B is equal to the sum of loop L added to the node N minus 1. As you can see here, this is our formula for branches. Number of branches is equals to the number of loop plus the number of node minus 1. Next is, if you're wondering what does it mean? What is Kirchhoff really mean? Does it really all about branches, node, and loop? So, it's me. Take a look at this example to understand further. So as you can see here, in this circuit, we have to determine how many branches, nodes, and loop. So remember the definitions we have told you a while ago, that these are the parallel circuit. This is number 1 branches. As you can see, number 1 branches. Any element connecting, this is an element. This is ampere. So this is 1 and this is 2. Here, from A to B, having an interconnected with 5 ohms. So A to B, 1 and 1, so 2. From here to here, 3. From here to here, 4. From here to here, 5. So all in all, we have 5 branches. So if you're wondering why I did not include this one, why? Because it has no element. So this is not considered branches, rather. So we already have known the branches in this circuit. So now let's look for how many nodes are in this circuit. Again, nodes or branches are interconnected or connected in a point in a parallel circuit. So for me, it is very helpful that we imagine how this circuit goes along when we connect these branches together. Okay, so if I can draw here, no, it's not working. So let's say, for example, from this load, from this ampere, we are going to connect that to point A, and then from A we are going to connect that to B, crossing the 5 ohms resistors here, and from point B we are going to connect that to point C, passing to 2 ohms. From point B we are going to connect that to this 3 ohms to the point C, and from point B again we are going to connect that, passing 2 ampere to the point C. So imagine how many points or how many parallel branches are connected to this point B. Again, this has 3 branches. Very good. So from point B, we connected 3 branches. So 1, 2, and 3. So again, branches that are interconnected or connected in a point, this one, in a parallel circuit are considered a node. Okay, understand? Next is this one. If we are going to look for a loop is any circuit in a closed path along a circuit that does not encounter the same node more than once. So then you can just use fundamental formula, which is B is equals to L plus N minus 1. Then arrange it so you can find loops. So B, or branches, minus node plus 1 is equals to loop. As long as we have any closed path that we can create a loop. This is done counterclockwise from here to here, here to here, here, and here. Counterclockwise. To substitute it, 5 minus 3 plus 1. This is already arranged from here to here. B, so I transposed it so I can find the loops. This is 3 loops. 1, 2, and 3. 3 loops that are not connected in the same node more than once. Okay? So if you understand these basic terms, now you are ready to understand what is really the Kirchhoff's law. The Kirchhoff's law has 2 laws, as you can see here, the KCL and KVL. Kirchhoff's current law, also known as KCL, states that the algebraic sum of current entering a node or a closed boundary is 0. For the second one, we have Kirchhoff's voltage law, states that the algebraic sum of all voltages around a closed path or loop is 0. So here, summation, and then from 1 to n, I sub k is equals to 0, and for our KVL, from 1 to n, V sub k is equals to 0. Next. So in this case, remember that current has direction. We have positive or negative. Let us say that entering a node are positive and leaving are negative. So these are entering, these are leaving, the I5 and the I2. So next slide, you can see here the equation is equals to 0. These are leaving and leaving, that is why negative. And positive, 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 because these are entering, equate to 0. And if we derive this equation, we can get a total current flowing on the system is total of I total is equals to I1 minus I2 plus I3, and this equation represents a one-wholeness for a current source. And from A, 1, 2, and 3. Okay? We can actually equate this to the totality flowing current in this circuit. Next is the KVL. This is a KVL. Oh, again, I forgot. When we are dealing with KCL, it deals with parallel because it has a different loads. You can have resistors, amperes for that. While on the other hand, Kirchhoff's voltage law or KVL, usually it deals with series. So this is an example of series. So Kirchhoff's voltage law states that the algebraic sum of all voltages around a closed path or loop is 0. Remember that one? There are 2 voltages, and with these 2 sources, you can create a loop. So from creating a loop, it's either clockwise or counterclockwise. It really depends on you because either way, it results or it equates to 0. So, but in this case, we usually do it counterclockwise. As reference here, our reference for KVL is that it deals with voltages. Also V1, negative V1, that is positive now, here, so as you can see the difference, plus the V4. Okay, so in this case, you already have arranged it, and this is the final formula for it, or equation for this circuit. So, for you to understand further, I leave you this kind of circuit. So from this circuit, okay, from this circuit we have positive, negative, positive, negative, positive, negative, V1, V2, V3. We have negative VA, A and B. So negative, positive, and like that. And then from here to here, V1, V2, V3. So these are same polarity. So we can just reduce this into this one, smaller one, put the polarity in this case, positive, negative, and then as for this polarity, we have VAB is equals to V1, here V1, plus V2 plus V3 are the equivalent circuit. So you have now the equivalent circuit and the original circuit. So this is way much easier to determine and easier to understand. So that would be all for our basic tackled discussion about Kirchhoff's law. So, and I hope that it helps you to understand the Kirchhoff's law. Thank you, and God bless us all.